Hello guys, in this video I'm going to share with you one important topic in computer networking, and this is the concept of variable length subnet mask, or the VLSM. So I'm going to give one example, and then we're going to design an IP addressing table based on the given actual scenario. But first I want to define first what is the meaning of the VLSM. Alright, so VLSM is a variable length subnet mask. It is a subnet design a strategy that allows all subnet masks to have variable sizes. In VLSM subnetting, network administrators can divide an IP address space into subnets of different sizes, and allocate it according to the individual need on a network. So this type of subnetting makes more efficient use of given IP address range. So what the network designer do will be dividing a subnet into another subnet to make it a different sizes, and in doing that, the network designer will arrive on the different subnet masks because he's going to subnet a given subnet. Alright, so now what is the comparison between the fixed length subnet mask and then the variable subnet mask? Ordinarily, if you're going to subnet a particular network ID, the fixed length subnet mask is an old strategy, and then the variable length subnet mask is the modern technique, or the modern strategy in designing an IP addressing scheme. And they also use VLSM when it comes to applying the latest routing protocol like OSPF version 2, RIP, or the routing information protocol version 2 also, and then the EIGRP. These are the protocols that can be that is compatible with VLSM. Unlike the fixed length variable subnet mask, it doesn't work in the new protocols or routing information protocols, or the protocols. The second comparison is the fixed length subnet masks have an equal size. Okay, and then subnets are variable in size. Subnets are equal in size because after you subnet a particular given network ID, all the subnet masks are all the same with the different subnets. Whereas in a variable subnet mask, the subnet mask of the subnet are of different size. That's why in the VLSM it is very important to use the CIDR, or the classless interdomain routing notation. And then number 3, subnets have equal number of hosts. So in fixed length subnet mask, they have equal number of hosts, and in variable they have variable number of hosts. It depends upon on the given subnet mask. And then in fixed length subnet mask weighs more of IP addresses as compared to variable length subnet mask, which is weighs fewer IP addresses. Subnets also used in fixed length the same subnet mask as I said a while ago, and then the variable subnet mask has a different subnet mask. Okay, so let's start with the So let us try to answer this given actual problem. So in this problem, the network consists of 3 LANs: local area network 1, LAN 2, LAN 3. These 3 LANs are connected with 3 serial links: link A, link B, and link C. Usually this link is connected with another link using a routers. Okay, and then the router's gigabit interface is connected to a layer 2 switch having 3 computers on it. So design an IP addressing scheme for the network using VLSM given the IP space of 192.168.20.0. So in this scenario, we only have given class C IP address, which is 192.168.20.0 is last 24. So it's not yet subnetted. Now, the host requirements of this given scenario, for local area network 1, he has 28 hosts. That means we need 28 IP addresses. And LAN 2 is 58 hosts. LAN 3, 10. And the link between the 3 routers needs 2 hosts each. Okay, so in this kind of scenario, we need first to subnet. We need to identify how many networks. So obviously, the total networks are 1, 2, 3, 6. So the total given networks we have 6 based on the given 1, 2, 3, 4, 5, 6 with the different host for each network. Now, to apply subnetting, in subnetting, out of one network ID, we need to subnet in order to divide this one network into several subnets. That's why that is subnet. Now, in subnetting, we borrow bits from the original subnet mask. Okay, so based on the given, the slash 24 here, the 24 here means the original subnet mask will be that is 24 bits, 25.255.0. So this is the original subnet mask before subnetting, and this is the default subnet mask for class C. Now, in order to subnet this IP address or network address, we need to borrow bits from subnet mask. In this case, we need to borrow bits from the last octet. Okay, so if we're going to get the last octet is 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8. So each octet has 8 bits. Now in subnetting, we are borrowing bits from left to right. From left going to right. From here going to right. Borrow bits. Okay. Now how do we know how many bits we need to borrow from this host bit? Using the formula, we have the formula 2 raised to n is equals to or greater than the number of networks. Now in this case, we already know that our networks is 6. We need 6. Okay, and n here is the number of bits that we are going to borrow. Okay, so by inspection, in order to satisfy this equation, we need to borrow bits. Now the question is how many bits to be borrowed in order to arrive at to satisfy this equation. Starting from right, going to left. Okay, so if we're going to borrow one bit, that is 2 raised to 1, that is only 2. Not possible. Now if we're going to borrow 2 raised to 2, 2 raised to 2 is 4. It's still not enough. It's 4. So it's still not enough. If we're going to borrow another bit, 2 raised to 3, sorry, 2 raised to 3, does it satisfy the given equation? Equal to or greater than. It should be equal to or greater than the original, which is 6. If we're going to get the answer, 2 raised to 3 is equal to 8. Since it satisfies this equation, because the equation tells us it should be equal to the original or greater than from the original number of networks. So in this case, we need to borrow 3 bits. After borrowing bits, we'll just rewrite the remaining zeros. So this will be, after borrowing bits, this will be the new subnet mask. Now this is now what we call subnet. Okay? And then after determining how many bits, we should know the last bit that we borrow. That will be our, this will be our increment. Okay, so, and this will be our new subnet mask. This is the original subnet mask. So the new subnet mask will become, we should always remember the positional value. The positional value of these 8 bits is 2 raised to 0 is 1, 2, 2 raised to 2, 2 raised to 1 is 2, 2 raised to 2 is 4, 1, 2, 4, 8, 16, 32, 64, and 128. That is the positional value of these 8 bits based on the 2 raised to 2, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, up to 2 raised to 7. That is the equivalent positional value. So in this case, this is 111. We need to add the value of 128, 64, 32. So therefore, the new subnet mask will be 255. That 255 that, if you're going to add this one, 128 plus 64 is 192 plus 32 and is equal to 224. So this will be our new subnet mask. Okay, so the equivalent CIDR, CIDR, or classless interdomain routing of this, that 24 is, just convert this to binary. We know that 255 is an 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, that 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and this one, that 1, 2, 3, 4, 5, 6, 7, 8. Just count the number of 8. So number of ones, this is 8 plus 8, 16, plus 8, 24, plus 3, 27. So CIDR value of 224 is last 27. That is how we get the CIDR notation. Just count the number of ones on the given subnet mask, sorry. Alright, so this will be our subnet. This is just a fixed subnet mask. So therefore, if we're going, our increment is the last digit. This is our increment, which is 32. This is the block, they call it block size of the subnet. So if we're going to write that one, Okay, the processing of my anyway. So if that is the, let me see, it was gone. Okay, so if we're going to write that one after subnetting, so we have a new subnet mask 192, sorry, 192.168.20.0, that is the original. Okay, so the CIDR notation for this is /24 without subnetting. And the next subnet, without changing the 3 octets, our increment is 32. Okay, so 32, after subnetting, we have a subnet mask of 224. Then plus 32, this is 64. Plus 32, this is 96. Plus 32, this is 678, 128. Plus 32, 8, 9, 10, 3, 4, 5, 6, 160. Plus 32, 190. Plus 32, 160, 160 plus 32, 160 plus 32 is 192. Plus 32 is 4224. This is the fixed length subnet mask. Okay, but we have 1, 2, 3, 4, 5, 6, 7, 8. We get 8 subnets, but actually our requirement is only 6. 1, 2, 3, 4, 5, 6. So this is the fixed length subnet mask. What we need is VLSM. So how we can apply the VLSM in this particular subnets? So these are the available subnets that we have. Applying the VLSM concept, okay. So in VLSM, we need to identify the number of, in applying VLSM, we should always start with the highest. Always start with the highest number of hosts. In this case is LAN 2 58. Okay, so in applying VLSM, we should always start with the highest number of bits. So the highest number of bits, the number of highest bits is 32. Always start with the highest bits at the highest number of requirements, which is in this case is 58. And the next is, what is the next? The next highest is 28 and 10. 28 and then 10, it should be in descending order, and then 2, 2, 2. This is LAN 1, LAN 2, This is LAN 1, LAN 3, and then this is the link. Link A, link B, and link C. That is our requirements. So we need to arrange our requirements according to the number of hosts, starting from highest. So the original, we should always start with the original. The original based on our subnet. First subnet is 192.168. I think we need to use the, I need to use blue color. So the original IP is 192.168.20.0. That is the original. Okay. Now, applying the VLSM. In VLSM, the first step is find the highest number of hosts, so 58. Now, in VLSM, we need to borrow bits from the host portion and then use the formula 2 raised to m minus 2 is equal to or greater than the number of hosts we need is 58. Again, a while ago in network, we used 2 raised to n only without minus 2. Minus 2 here indicates that network ID and the broadcast ID is not assigned as host address. So that's why they put minus 2. And then in VLSM, we are borrowing bits from right to left. It's a reverse. So if our subnet mask is after subnetting, if this is the original 1, 2, 3, 4, 5, 6, 7, 8, we borrow bits from the host portion. And a while ago, after subnetting, this is the new last subnet after subnetting. Now applying this formula, how many zeros from right to left, how many zeros do we need to get 58? How many zeros? 0. So if we're going to get 1, 2, 3, 4, 2 raised to 4 is 16 minus 2. It's not enough. The bit here will make it 0. 1, 2, 3, 4, 5. If we're going to borrow 5 zeros, 2 raised to 5 minus 2, does it satisfy is equal to 58, the original. 2 raised to 5 is 32 minus 2, 30. It's not enough. What about 6? If we're going to borrow 6 minus 2, does it satisfy? 2 raised to 6 is 64 minus 2 is 62. So having 6 zeros will satisfy the original equation. It should be greater than or equal to the original number of hosts. So therefore, we need 6 zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. This will be the host, and this is the new subnet. Okay, the new subnet. Okay, it's a reverse of subnet a while ago. So this 2 is subnet. This 2 is the subnet, and this is the host. Okay, so therefore the new subnet mask now is 1 1 1 2 3 4 5 1 2 3 4 5 6 8. This will be the new subnet. What will be the value of these two? This is 128 plus 64. That will be 192. And what will be the equivalent CIDR? So as I said a while ago, we need to count the number of ones. So that is already 20 for the first three. 255, that 255, that 255. The new value of subnet now for our VLSM is 192. So if we're going to count the number of ones, this is 8 ones, this is 8 ones, this is 8 ones, 24 plus 2. This is equal to 24, 26. So the CIDR notation of this is /26. So therefore, and then identify what is the last bit for the subnet. This will be our increment. And this increment is equivalent to decimal value of 64. This will be our increment. Okay, always the last digit of the subnet from left to right. So therefore, our next subnet should be an increment of 64 from the original 0 plus 64. So these 3 octets will not change. So this will be the next subnet. Okay. VLSM, after VLSM. Now, what will be the CIDR of this is, we should always start with the first subnet, that is .0, the original. So therefore, /26 will be here. This will be the /26. And then the new subnet is .192. Okay, that is the, if you're going to add this one, 128 plus 64 is 192. So from this range, 0 to 64, what is our first usable network? This is .1. 0, .1 up to .62. This is the valid usable host because the number before the next subnet will be our broadcast. Our broadcast here is 63. Okay, so 192.168.20 will not change. So this is for LAN. This is our LAN. LAN 2. LAN 2. I think I need to type this one. That is for our LAN 2 requirements. Okay. So okay, so moving on, our next requirement is 28. Our next requirement is 28. We need to erase this one. So our next requirement is 28. 28. 2 raised to m again is equal to minus 2 equal to greater than 28. So how many zeros again we need in order to satisfy this equation? 28. So if we're going to have 4 zeros, this 16 minus 2 is not enough. If we're going to borrow 5, 2 raised to 5 is 32 minus 2 is equal to or greater than 30. Okay, so 30 is enough. It is greater than the original, so therefore we need 5 zeros. So again, from the previous subnet, 5 zeros. So 1, 2, 3, 1, 2, 3, 4, 5. We need 5 zeros to satisfy the equation. So therefore, this will be our new subnet, which is equivalent to 128 plus 64 plus 32. This is 224. This is dot 24. Our new subnet will be 255.255.255.224. And the CIDR notation for this is 24 plus 3, 27. So therefore, our CIDR here is 27. Now, in this new subnet, what will be our increment? This is our increment. Always the last bit. And this is 32. Our increment is 32. All right? So, in order to get the next subnet, we increment 32. So, we add 32 in 64. 64 plus 32. This is 696. Our next subnet is 96. Okay? And we use the next subnet. Here is /27. This is that 224. So they have different subnet mask. And then the host range, the first usable is from this subnet 64. So this is dot 65. This is dot 65. Up to, so 95 is the broadcast. So that 94 is the last usable. And then the broadcast is always the number before the next subnet. So therefore, this is 90.95. So we have 95. There's a problem with my, I think I need to write now. So that 95. That 95. Okay, so this will be the, and then our, this is for LAN number 1. Okay. Now our next requirements will be, the next highest number is 10. What will be our new subnet now? And then get the increment. So using 2 raised to m minus 2 greater than, this is the requirements. So how many zeros do we need? From the original subnet, 2, 3, 4, 5. 2, 3, 4, 5, 6, 7, 8. We need, if we're going to need 3, 2 raised to 3 is only 8 minus 2 is not enough. If we're going to use 4 zeros minus 2, this is equal to or greater than 2 raised to 4 is 16 minus 2 is 14. So it satisfies because it is greater than the original 10. Satisfies the requirements. So we need 4 zeros. We need 4 zeros. So what will happen to the 0? It will become 1. So that will be our increment, which is, this is 1, 2, 4, 1, 2, 4, 8, 16. And this will be our new subnet mask. If you're going to add this one, again, 128 plus 64 plus 32 plus 16, this is 224. This is 224, 240. This is 240. Because 3 is 224 plus 16, 1, 2, 4, 8, 16 is 240. And the equivalent CIDR is 24 plus 4 is 28. So therefore, increment of 16, the next subnet will be 96 plus 16 will be 12, carry 1, 9, 10, 11, 112. 112 is the next subnet. Okay, and then we'll put here our next CIDR is slash 28. And this is the 240, our new subnet mask. And then the first usable is from this range, 96, this is 97. And then the last, before the last address, this is 110. Okay, and then before 112, that is the broadcast, this is 111. And this is for LAN. Three. That is for LAN 3. Okay. And then we will write here link A, link B. This is the remaining network. And then we have link C. So what will be the next? For link A, we only need 2 hosts. Okay? We only need 2 hosts. Let us erase this one. So we only need 2 hosts. Our last subnet is 112. So what will be the increment? The increment will be based on the next subnet that we're going to get. So 2 raised to m again. Oh, no need to write again. Just erase this one. We need 2 hosts. So to satisfy this, if we're going to have 2 minus 2, this is equal to 2. So it satisfies because the condition is equal to or greater than 2. So we need 2 zeros to be retained in the subnet. So if this is our subnet, 1, 2, 3, 4, 5, 8, we only need 2 zeros. So the rest will be 1. Okay, so this will be our increment, which is 1, 2, 4. And then if we're going to add this 6 ones, this is 252. Sorry. 1, 2, 3, 252. Yes, 252. So this is our new subnet, and we have, this is equivalent to slash 24 plus 6, this is 30. Slash 30 because 30 number of ones. So therefore our plus 4, the last subnet is 112 plus 4, this is 116. And then we need another one because all of them are requirement are 2. So just increment it by 4. This is 120 plus 4. This is 124. Okay. So all of them 114. This is 1.116.11 or 120. Sorry. So this is 120. This is 116, and then this is 120. And then they have the same cider slash 30 slash 30. And they have all the same subnet mask 252, 252, 252. Okay. So to get the range of the first link, starting from 112, so the first is that 113. 112, 113, and then that 114. I'm always having a problem in this part. This is 114. That before 116, this is 115. 115. Okay. And then our next link, link B, in this range, 116. So this is 117. And then 118. And then the last IP is 11, the broadcast is 119. Because the next subnet is 120. What about the last? The last is what range? So if you're going to add another 4 plus 4 increment, this is 128. 120 plus 4, sorry. Plus 4, we still need here 124. That 124. So our range from 120 to 124 will be the host range 121, 122, and then the last will be 123, the broadcast address. Okay, so these are the VLSM, these are the complete VLSM table. So we satisfied all the requirements. So this one unchanged, the same one, 192.168. No change, 192.168.20 up to here. the same. It's nothing, only the fourth octet are changing because that is where we subnet. So if you notice, the distribution of the host addresses are efficient. Okay, so from 162, then 64, 65, 65 to 94, 95, 97 to 110, 112, 113, 114, all host addresses are being used. There is no waste. If there's a waste, only a few host addresses. So this is the concept of VLSM. Take note, this is class C. The same procedure when you are in my next video, I'm going to create a video of VLSM using class B and class A. It's a little bit more difficult than class C. Okay, so thank you so much for watching this video. So I hope you learned something in this video, and see you on my next video. Thank you so much.